Chapter 14 review. I know we have a test today, so I want to make sure we get a review done. So 14.1, understanding polynomials. So that gets into how do we name them, how do we combine like terms, things like that. We want to make sure that you understand all the different parts of polynomials. And then 14.2 is adding, subtracting polynomials. So we're either distributing a positive one or a negative one pretty much to the second polynomial. 14.3, applying multiplying polynomials by monomials. So that's just distributing, knowing how to multiply constants times constants, and what's really important is multiplying a variable times itself. Um, so that's adding powers as you go through and then multiplying polynomials, period. So we can have a binomial times a binomial. So we'll use FOIL, or we'll have monomial times anything, 4 terms, 6 terms, whatever the case may be. Okay, so 14.1, understanding polynomials. Well, the first thing we have to know is how many terms are there? Terms are separated by what in a polynomial? A plus sign or a minus sign. So if I have 3x plus 4x squared minus 6, how many terms do you see there? 1, 2, 3. So 3 terms is called what? Trinomial. Okay. Naturally, we would list it with the highest degree first, then the next degree, and then the constants are always what? Last. Okay. So what if I had 2x minus 6? How many terms do you see? There's 1, there's 2. So that is called a what? Binomial. Okay. And then if I plainly have 6 y to the third, what is that called? How many terms? It's just 1. So that is called a monomial. Okay. So you should see mono, bi, and tri. Now here's the thing. Monomials build all the other ones because this is a monomial, this is a monomial, 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 and another monomial. So we have to know monomials are made up of what? Well, it's easy to say what they are, okay? But really, it just is a constant of some sort, and there could be a combination of a constant slash variable, okay? Doesn't have to be both. It could be one or the other, or a combination of the two, okay? But what can't it be? Okay. Well, we can't have what? Variables in the what? Denominator. In the denominator, okay? So if we had, for example, 3x squared, this is not a monomial. No. Okay, just bounced on me. This is not a monomial, okay? What else can't happen? We can't have where there's a negative exponent. So no negative exponents. So if I had 3x to the negative 2, this is not allowed. Okay, no negative exponents. So we want to make sure that, okay, and then that's pretty much, oh, no fraction, no exponents that are fractions. Okay, So if I had 3x to the 1/2, okay? Because here's the thing, let me just explain the reason why. That really means square root. So this is 3 times the square root of x. So no square roots or no powers to a fraction, okay? I could have 3y to the 1/3. That's really 3 cube root of x, okay? So these are not allowed to be monomials. So they can't construct our polynomials as we go through, okay? What's the other thing you need to know? The degree of a monomial, okay? So remember, a monomial could just be a constant. So 6, there we go. That is a monomial. I also could have 8. How else can I write 8? 8 is 2 to the what? 3rd power. We do not count the power if it's just a constant, okay? Because we can do that. We know 2 to the 3rd power is really 8, and that's 8 to the 1st power, okay? But if I look at x squared plus x, well, if it's unwritten, then I know the power is 1. Which one has the highest power? 2. So the degree is called a second degree. Okay. What if I have 4x plus x squared? Well, this is really a 1. This is 2. So it's still a second degree polynomial, okay? Regardless of the 4, we only look at the powers of the variables. So if I have y to the 5th x squared plus bc. Well, now I have a 5 and a 2, so I add them. So that gets me 7. This is a 1 and a 1, so that gets me what? 2. Well, 7 is bigger than 2, so I get a 7th degree polynomial. And now, if I want to write out what the polynomial is, how do I do that? I do the degree first, and then I write the amount of terms. So if I have 3x squared plus x minus 1, what's the highest degree? Well, 2, okay? So I have a second degree. How many terms are there? 1, 2, 3. 3 terms is a trinomial. Does that make sense? So if I have 4x to the 5th, y to the 2nd, plus x to the 10th, y minus 8. Well, here's 5 and 2, which gets me 7. Here's 10 and 1, which gets me what? 11. So I get a 11th degree. How many terms? 1, 2, 3. Separated by plus and minus signs, right? That is a trinomial. And that's how you sit there and identify polynomials. So 14.2, adding and subtracting polynomials, really, it's just distributing the one and then combining like terms. So combining like terms is a huge term here. If I say 3x squared plus x minus 2, and I want to add x to the 4th minus x squared plus 8. Okay, well, first thing I would do, there is a understood 1 here. So when I distribute that, what happens? Nothing happens with the signs. I just can say 1 times x to the fourth. 1 times anything is itself. So the parentheses drop. So I get what? 3x squared plus x minus 2. 1 times x to the fourth, x to the fourth. 1 times negative x squared, x squared. 1 times 8, 8. So now I can combine like terms. Is there an x squared somewhere? Yes. Remember, keep the signs. Is there an x to the first? Just that one. Is there any constants? Yes. The 2 and 8. Is there an x to the fourth? It's just that one. So how do I write this? Always put the highest power first. So that's this 4. So I have x to the fourth. Then I do the next highest power, which would be 2. So this is 3. This is an understood 1. 3 minus 1 is what? 2. So I get plus 2x squared. Notice I subtracted 3 minus 1. The coefficients, I kept the variable the same and I kept the power the same. When we're adding and subtracting, you have to know that, okay? What's the next highest power? The x to the first power, right? So plus x. Then what goes last? The constants. So 8 minus 2 is what? 6. Now I can label this. What's the highest power? 4. So I have a 4th degree polynomial. It's not a monomial, it's not a binomial, it's not a trinomial. So I just put 4th degree polynomial because it's more than 3. Okay? What if I want to subtract? So let's say that I have negative 3x to the fourth y minus 6x squared y plus 9xy minus 8. And I want to subtract from it 8x to the fourth y plus 6xy minus 20. Know that what? Here's a negative 1. So what do? Distribute the negative 1 into this second parentheses. Does anything happen to the first one? No. So I'm going to just repeat it. Negative 3x to the fourth y minus 6x squared y plus 9xy minus 8. Now, when I distribute a negative 1, what's going to happen? All the signs are going to change. So it becomes negative 8x to the fourth y, negative 6xy plus 20. So negative 1 times error, negative 1 times error, and negative 1 times error. Now I got to combine like terms. Is there an x to the fourth y? Yes. Circle the sign with it, okay? Is there an x squared y? No. Is there an xy? Yes. So I circled the sign with it. Are there constants? Yes. So I have 3 different things that I need to combine. I write the highest power first. Well, 4 and 1 is 5. So those are the highest powers. So let's combine those up, okay? Negative 3 minus 8. Same sign, add. So I get 11. Keep the sign. So negative 11. X to the fourth y. Notice I kept the same variables and I kept the power. When I'm adding and subtracting, I have to do that. Okay. The next highest power is the x squared y, because that's 3. The next highest power will be this 1 and 1, which is 2. So 9 minus 6. So 9 minus 6 is 3. So I get plus 3x to the first. X to the first, y to the first. And then negative 8 plus 20, I get plus 12. Again, what's the highest power? It'll be right here, 4 and 1. So I get a 5th degree. It's more than 3 terms, so polynomial. Okay. 14.3, multiplying polynomials by what? Monomials. This is straightforward. This is nothing more than distributing. Okay. This is all that is. So 3x to the third y. Here's the thing though. We're now multiplying variables times variables, which means we need to be able to add the powers. Okay. So 6xy minus, let's just say b. Okay. So now when we distribute, it goes into each term. So this says what? 3x cubed y times 6xy plus 3x cubed y times negative b. So that's how we write that, okay? So 3 times, always do the constants first. So 3 times 6. 3 times 6 is what? 18. Now I look at my x. I have an x. Here's a 1 and a 1, right? So this says x cubed times x to the first. So that means 3 plus 1. What's 3 plus 1? 4. So I get x to the fourth. Now I do y and y. This is to the first power. This is to the first power. So y times y. 1 is equal to y. 1 plus 1. So I get y squared. You add the powers when you multiply. Okay. Here comes the plus. But I know that this is a positive times a what? Negative 1. Correct. So 3 times negative 1 is negative 3. Okay. Now, x times a b, y times a b, we just write it out. X cubed. Well, b would go first because we put it in alphabetical order, right? So b, x cubed, y. So my final answer is right there. 18x to the fourth, y squared, minus 3b cubed, y. So here we go. What's the highest degree? 4 and 2 is 6. This is a 1, this is a 1, so I get 5 over there. So I have a 6th degree. How many terms do I have? 2. So binomial. Okay. Let's multiply out just a constant. 3x plus y. Distribute in. Doesn't matter if it's constant, doesn't matter if it has variables. Either way, you can multiply. Multiplying, you can do everything, okay? So this is 3 times x plus 3 times y. 3 times x is 3x. 3 times y is 3y. Done. Highest power is 1, so I have a first degree. How many terms do I have? 2. Binomial. Okay. What if it's b, and I put b minus c? What is that equal to? Well, I distribute into both. So I get b times b plus b times negative c. B times b, this is the first power. So what do? 1 plus 1, which is equal to what? 2. So I get b squared. Now plus positive times a negative. This is a positive 1. This is a negative 1. 1 times negative 1 is negative 1. And then I just write bc. What's the highest degree? 2. So second degree what? Yep, 2 terms. So it is a binomial. Okay. Now, here's the combination. So 3, let's put a negative. And let's put g. And I want to multiply it by what? B squared minus c cubed plus 8gm. Let's make that to the fourth minus 6x plus 8z minus 9. So you're looking at that and going, oh my goodness, Mr. Harris. Well, all I'm going to do is distribute that to every term. Doesn't matter how many terms I see, I distribute it to every term. So I have 1, 2, 3, 4, 5, 6 terms. So I'm going to multiply it to 6 terms. So what is that? Negative 3g times what? B squared plus negative 3g times what? Negative c cubed plus. Notice I added all these up. I keep the negatives inside. So negative 3g times 8g to the fourth m plus negative 3g times negative 6x plus negative 3g times 8z plus negative 3g times negative 9. And now you just walk through it, okay? Constant times constant, and then variable times variable. So here's a negative 3, here's a 1. So I get negative 3. G times b, I'm going to put the b first. B squared g. Alphabetical order, right? A negative and a negative. Negative 3, and this is negative 1. Gives me a positive 3. G and c cubed, so c cubed g. Negative and a positive. Negative 3, positive 8 gives me a negative 24. G and G. So here's 1. 1 plus 4 is what? 5. So G to the fifth M. Negative and the negative gives me a positive. So positive 18. G and X. So G times X. Negative 3, positive 8. So that is negative 24. A G and a Z. Negative 3, negative 9. That's a positive 27 G. And they're all in order right from there. And I know that the highest one, here's 1, 2 and 1, that's 3. Here's 3 and 1, that's 4. Here's 5 and 1, that's 6. Here's 1 and 1, that doesn't work, 1 and 1, and here's 1. So 6. So I have a 6 degree what? It's more than 3 terms, so polynomial. Okay? Okay, multiplying polynomials. So the first one is a binomial times a what? That's right, binomial. Okay, and what do we use to do that? FOIL. What does FOIL mean? First, outer, inner, last. This is nothing more than distributing, but we gave it an order, so it tells you what to do. Okay, so now if I have x plus y times 3 plus y. First, outer. So first, outer. Inner. Last. FOIL. Creates 4 different equations. So I get x times 3 plus x times y. Notice I'm taking the first term and I'm multiplying it into each term in the second binomial. Then I take the second term and I do the same thing. Y times 3 plus y times y. And that's how you get 4 different equations, okay? X times 3 is nothing more than 3x. X times x is nothing more than xy. Y times 3 is nothing more than 3y. And y times y is what? Y squared, because this is 1, this is 1. So 1 plus 1 is 2. Okay, anything to combine? Nope. It's in alphabetical order. I am good to go. So let's do another one. Let's say 3x squared plus y squared. I want to multiply that by just a plain old xy. So again, distribute, distribute each term. Distribute, distribute. First, outer, enter last. So that gives me what? 3x squared times x. First one. Add to it 3x squared times y. Notice I take the first one and I multiply it by each term. Okay. Then I add to it the second term. So y squared multiplied to the x plus y squared times y. So the second term, and I multiply it to each term in the second binomial. So here we go, 3x squared times x. So this is a 1. So 3 times 1, 3. 2 plus 1 is 3, so I get 3x cubed. Here's 3 times 1, so I get a plus 3. X squared times y is x squared y. Here is a 1 times 1, so I get a positive 1. Y squared times x, I get x y squared, put it in alphabetical order. Plus 1 times 1, so I get plus 1. 2, y squared times y, that is 2 plus 1, so I get y cubed. Now, usually do we write these ones out here? No, but I need to make sure you understand it's constant times constant. So there is a 1 there, okay? It's in alphabetical order, so I'm good to go. Now, what if it's not just a binomial? Let's say I have x plus y, and I want to multiply it by 3x squared y cubed minus 6xy plus 8. I can do that. I can multiply it all the way out. First term times each of the terms in the second. Second term times each term in the second. So we don't call it FOIL, but it's distributing. You have to make sure that each term in the first polynomial is multiplied to each term in the second. Okay? So here we go. I get x times what? 3x squared y cubed. Add that to x times what? Negative 6xy plus x times what? 8. See how you did that? There's 3 arrows. There's 3 different equations. Now I do the same thing with the y. Y times what? 3x squared y cubed plus what? Y times what? Negative 6xy plus what? Y times 8. And now all I do is combine these out by multiplying. So I get what? X times that, it's 1 right here. So 1 times 3 is what? 3. X times x, there's a 1 there. So 1 plus 2 is what? 3. Then bring the 3 along. The y along. So y cubed. Here I got a 1. 1 times negative 6 is negative 6. Here's an x, here's an x with powers of 1. So I get x squared. Then bring the y along. Plus, here's a 1, here's an 8. So I get plus 8 times x. Over here is a 1. So I get 1 times 3 is a positive 3. X goes first, so x squared. Here's a 1. 1 plus 3 is 4. So I get y to the 4th. Here's a 1. 1 times negative 6 is negative 6. So keep the x. This is a 1. This is a 1. So I get y squared. Here's a 1. 1 times 8 is 8. And we times it by a y. Okay, so the highest degree here is 6. 6, yep, so it's the 6th degree, what? Polynomial. Good. Now, let's see. Is there anything that matches first? No. None of them match. Here's a x to the 3rd. There's no other x to the 3rd. Here's an x squared. Here's an x squared, but this is y to the 1st, y to the 4th. So that doesn't work. Here's an x to the 1st. Here's an x to the 1st, but they also have a multiplied by y. And here's y all by itself. So there's no like terms there to combine.